Welcome to this harbor beneath the stars. Wherever you may be, let the sounds around you fade away. Gently bring your attention back to your breath. Each inhale gathers scattered starlight. Each exhale releases accumulated weariness. Tonight we embark on a special journey, a cosmic voyage through time and space. You need not memorize any facts nor ponder complex questions. Simply find your most comfortable position and let your thoughts drift gently with my voice. We'll begin at the universe's origin, wander into the distant future, passing through the birth and death of stars, exploring mysterious black holes and dark matter, finally returning to this tranquil night. Now, if you're ready, please gently close your eyes. Let us begin this serene cosmic journey. The ancient growth rings of our universe, a 13.8 billion-year story, modern astronomy tells us. The universe has traversed 13.8 billion years of time. This figure stems from precise measurements of the cosmic microwave background radiation and ongoing observations of galaxy recession velocities. Over such an immense span, stars have been born and died, galaxies have formed and evolved, and life has blossomed on Earth. When we gaze at the night sky, what we see is not merely spatial distance, but temporal antiquity. Some starlight began its journey before Earth had formed, before life had sprouted. And tonight, these ancient photons finally reach your eyes, completing a journey spanning billions of years. The Big Bang was not a loud explosion, but the birth of space. The universe did not emerge from an explosion within existing space. Rather, it was the birth and expansion of space itself. In the first instant, there was no up or down, left or right, no past or future. All matter and energy were condensed into an infinitesimal point. As space-time began to expand, energy cooled, gradually forming fundamental particles, then atoms and molecules, until the vast starry seas of today. This understanding reveals we are not mere observers in the cosmos, but integral parts of the universe itself, breathing with it, growing with it. In the very first instant, the universe underwent expansion faster than light. Within the first second after its birth, an astonishing period of inflation occurred. Space expanded by dozens of orders of magnitude in an incredibly short time. During this process, the rate of space's expansion far exceeded the speed of light. Yet this did not violate physical laws, for it was space itself stretching. The theory of inflation explains why the universe is so flat, and why distant celestial bodies appear so uniform. This initial rapid expansion planted the primordial seeds for all subsequent structures. The universe's oldest photons still traverse the space around us. When we tune to the right frequency, we can hear the cry of the infant cosmos, the cosmic microwave background radiation. This is a photograph of the universe at 380,000 years old, when it first became transparent, and photons could travel freely for the first time. These ancient photons, after a 13.8 billion-year journey, have cooled to near absolute zero, yet they persist, filling every inch of space around us. When you listen in stillness, you might sense this greeting from the universe's dawn, the cradle of stars, nebulae drifting through space. Amid the spiral arms of the Milky Way, vast molecular clouds float. These nebulae, composed of gas and dust, are the birthplaces of stars. When density in a region becomes sufficiently high, gravity takes hold. Matter coalesces toward the center, temperatures gradually rise until nuclear fusion ignites. A new star is born. The rich elements within nebulae provide essential building blocks for our planetary systems to form. Our own solar system emerged from such an environment. The sun's steady burn is a nuclear fusion process that has endured for 4.6 billion years. The sun's core functions like a colossal nuclear reactor, converting 600 million tons of hydrogen into helium every second, with 4 million tons of matter transformed into pure energy. This energy takes tens of thousands of years to travel from the core to the surface, then another 8 minutes to traverse Earth's atmosphere, warming our skin, nourishing life on Earth. The sun has burned steadily for 4.6 billion years and is projected to continue for another 5 billion years. Its light is the wellspring of life on Earth and one of the universe's longest-lasting. The most massive stars lead brilliant yet fleeting lives. Some possess dozens or even hundreds of times the sun's mass, burning with extreme intensity. Within mere millions of years, they exhaust all their fuel. Unlike the sun's gentle stability, these giants' existence is filled with passion and explosions. Through nuclear fusion, they forge the heavy elements of the cosmos, providing the rich chemical elements for subsequent generations of stars and planets. Though their lives are fleeting, they make an indelible contribution to the chemical evolution of the cosmos. Supernova explosions, the universe's most spectacular farewell. When massive stars reach the end of their lives, they bid farewell to the cosmos through supernova explosions. Within mere weeks, a single supernova may release more energy than an entire galaxy emits. This dazzling explosion scatters the heavy elements forged throughout the star's lifetime into the surrounding interstellar space, becoming raw material for a new generation of stars. All heavy elements on Earth, including the calcium and iron that compose our bodies, originate from ancient supernova explosions. We are inheritors of the stellar legacy. White dwarfs, the slowly cooling embers of stars extinguished in space, medium-mass stars like the sun, evolve into white dwarf at life's end. These Earth-sized bodies boast densities of several tons per cubic centimeter. No longer fueled by nuclear fusion, they glow solely from residual heat. Over the next billions of years, they gradually cool to become frigid black dwarfs. Yet the universe remains too young. No white dwarf has yet completed this cooling process. All quietly, emitting their lingering glow across cosmic corners. Neutron stars, cosmic curiosities where a teaspoon weighs as much as a mountain. When more massive stars die, they may form neutron stars. These celestial bodies, only city-sized, possess masses exceeding the sun's. Their density is so extreme that atomic nuclei are tightly packed together. A single teaspoon of neutron star material weighs over 1 billion tons. Some neutron stars spin rapidly, emitting rhythmic pulses. As the universe's most precise timekeepers, their existence proves how extreme matter can be compressed. Black holes, gravitational abysses where even light cannot escape, In gravity's ultimate triumph, black holes are born. These most enigmatic cosmic bodies are formed from gravitational fields so potent that not even light can escape their surfaces. Black holes are not cosmic vacuum cleaners. They are merely special regions of space-time orbiting at safe distances, much like orbits around ordinary celestial bodies. But the moment one crosses the event horizon, there is no return. Though invisible, we confirm their existence through their gravitational effects on surrounding matter. The Milky Way, our spiral island universe, our home galaxy, a vast cosmos containing hundreds of billions of stars. The solar system lies within one of the Milky Way's spiral arms, approximately 27,000 light-years from the center. It completes one orbit around the galaxy every 230 million years. The Milky Way does not exist in isolation. It forms part of the local group, a cluster of dozens of galaxies. On an even grander scale, these galaxy groups belong to the Virgo supercluster. We are like a layer within the cosmic onion, both insignificant and uniquely distinct. The Andromeda Galaxy, our slowly approaching neighbor, visible to the naked eye on clear nights. The Andromeda Galaxy is drawing nearer at 110 kilometers per second. In about 4 billion years, it will rendezvous with the Milky Way. This cosmic dance will unfold over billions of years, ultimately merging the two galaxies into a larger elliptical galaxy. But fear not, during galaxy mergers, the probability of direct stellar collisions is extremely low. This grand cosmic event will unfold as a slow and graceful fusion. The large-scale structure of the universe, a cosmic web resembling a neural network. On the largest scales, the universe exhibits a web-like structure. Galaxies align along filaments of dark matter, forming cosmic filaments stretching hundreds of millions of light-years. Where these filaments intersect lie massive galaxy clusters, while the spaces between filaments are nearly empty cosmic voids. This structure resembles a neural network, or the skeleton of a phone, revealing the deepest architecture of the universe. Our own Milky Way galaxy is also a node within this vast web. Dark matter, the invisible hand shaping galaxies. By observing the rotation curves of galaxies, scientists discovered that the mass of visible matter is far insufficient to sustain the structure of galaxies. An invisible substance must exist to provide additional gravitational pull. This is dark matter. It does not interact with light and can only be detected through gravitational effects. Dark matter constitutes over 5 times the mass of ordinary matter, forming the bulk of the universe's mass. Though its nature remains unknown, one thing is certain. Without dark matter, there would be no galaxies and no us. Dark energy, the mysterious force driving the universe's accelerating expansion. Even more astonishingly, the expansion of the universe is accelerating. This implies the existence of a mysterious force, counteracting gravity's pull. Scientists call it dark energy. It appears uniformly distributed throughout space and grows stronger as the universe expands. Current understanding suggests dark energy accounts for 68% of the universe's total energy, determining its ultimate fate. We know very little about its nature, perhaps the greatest enigma in contemporary physics, gravitational lensing, how the universe bends light. According to general relativity, massive celestial bodies can warp surrounding space-time, causing passing light rays to bend. This phenomenon, akin to an optical lens, is known as gravitational lensing. By observing distortions in background celestial objects, we can infer the mass distribution of foreground objects and even uncover the structure of dark matter. Gravitational lensing allows us to see invisible mass, making it a vital tool for studying the universe. Time dilation. Time slows near massive objects. Within strong gravitational fields, the passage of time decelerates. This effect has been repeatedly verified by precise experiments. GPS satellites must account for time dilation. Otherwise, navigation systems would accumulate errors of several kilometers daily. Near extreme objects like black holes, time dilation becomes markedly pronounced. This implies time is not absolute, but intrinsically linked to the fabric of space-time. Gravitational waves, ripples in the fabric of space-time. When massive celestial bodies accelerate, they generate ripples in space-time. These are gravitational waves. In 2015, LIGO made the first direct detection of gravitational waves from the merger of two black holes. This discovery opened a new observational window, allowing us to listen to the vibrations of the universe. Each gravitational wave signal narrates a distant cosmic tale of collisions, of mergers, of the very fabric of space-time itself trembling. The speed of light, the ultimate limit for information transmission in the universe, in a vacuum. The speed of light is constant and unchanging, approximately 300,000 kilometers per second. This is the ultimate speed limit of the cosmos. No matter or information can exceed this velocity. When we observe distant galaxies, what we see is their past appearance, for light requires time to travel. Astronomical observation is fundamentally a retrospective view of history. The farther we look, the older the universe we see. Beyond our solar system, thousands of new worlds exist. To date, astronomers have discovered over 5,000 exoplanets. The diversity of these worlds is astonishing. Scorching super-Earths, giant gas planets, and Earth-like planets within habitable zones that may harbor life. Each newly discovered exoplanet expands our understanding of planetary systems and prompts us to ponder whether life is common throughout the cosmos. Habitable zone, the golden region where liquid water may exist on a planet. Surrounding a star lies a zone with suitable temperatures, where liquid water could persist on a planet's surface. This is the habitable zone. Too close to the star, water would evaporate. Too far away, it would freeze. Planets precisely within the habitable zone are considered most likely to harbor life. Yet life may also exist in other unexpected environments, such as the subsurface oceans of icy moons. Potential habitable worlds around red dwarfs. The most common stars in the Milky Way are red dwarfs. Smaller and dimmer than the Sun, their habitable zones lie closer to the star. This often causes planets to become tidally locked, with one side perpetually facing the star, while the other remains perpetually dark. Though peculiar, such conditions do not preclude life's existence. Atmospheric circulation can regulate temperatures, and life may thrive at the day-night boundary. These long-lived stars offer ample time for life's evolution. Are we the only intelligent beings in the cosmos? This question remains unanswered. The Drake equation attempts to estimate the number of intelligent civilizations in our galaxy, yet each parameter carries significant uncertainty. We have neither discovered definitive evidence of extraterrestrial life, nor proven that life is a miracle unique to Earth. This very uncertainty is a beautiful possibility that inspires us to keep exploring, to keep questioning the stars. The universe we can observe is finite, due to the finite age of the universe and the constant speed of light. We can only see a limited portion of it. The radius of this observable universe is approximately 46.5 billion light years. Celestial bodies beyond this boundary have not yet had sufficient time for their light to reach us. As the universe continues to expand, some galaxies will vanish forever from our view, because their recession speeds exceed the speed of light. The observable universe resembles an ever-shrinking island, yet we know that beyond this island lies infinite unknown awaiting discovery. The ultimate fate of the universe, a cold, silent heat death. Based on current observations and theories, the universe is likely headed toward heat death. As the universe keeps expanding, matter becomes increasingly sparse, stars gradually extinguish, black holes slowly evaporate, temperature approaches absolute zero. Ultimately, the universe will fall into eternal stillness. This process requires an extremely long time, far exceeding the current age of the universe. But this may be the ultimate destiny of the cosmos, a slow and solemn finale. The era we inhabit in the universe is precisely the golden age of stars. Interestingly, we happen to live at the zenith of this. The early universe contained no stars, and future stars will gradually fade away. Yet now, new stars continue to form ceaselessly. Galaxies brim with vitality, and the cosmos still holds ample heat and light. We inhabit the universe's golden age, able to gaze upon the starry sky and contemplate these profound questions. This itself is a form of luck, a precious karmic connection worth cherishing. Now let us conclude this cosmic journey and return to this tranquil night. Together we have traversed vast space-time, from the universe's inception to distant futures, witnessing stellar births and deaths, exploring galaxies and black holes, contemplating life and intelligence. This knowledge reveals Earth's preciousness in the cosmos. Each of us is forged from stellar matter, deeply connected to this universe. The universe's vastness reminds us that daily worries and troubles seem so small and fleeting before its billions of years of history. May this realization bring you inner peace. The darkness of the cosmos is not emptiness, but a tranquil backdrop brimming with possibility, just as night's darkness soothes weary souls. Now take several deep breaths. Feel your body touching the bed. Let the cosmic imagery fade from your mind, leaving only that profound stillness. May these tales of the stars lull you to sleep, guiding you into peaceful, serene dreams. Good night, my dear stargazer. May tomorrow's sunlight bring you fresh hope and strength. If you enjoyed this journey, please subscribe to our channel. Share this starry sky with more souls seeking